Give one reason why 0 is an even number. Actually, there's lots of answers accepted here, and here's a few. So -1 and 1 are both odd on either side of 0. You might say they alternate. Goes odd, even. So then, therefore, 0 is even. This is a good one because this is a good definition of an even number. It's a multiple of 2, so actually 0 can be divided by 2 exactly. I know you get 0, but you don't get a remainder. Numbers that end in 0 are even. Yeah, 0, 2, 3, 4. Sorry, 0, 2, 4, 6, 8. Next number pattern of even numbers, 8, 6, 4, 2, 0. That's another one. Or added to an even number, it gives an even answer, and added to an odd number gives an odd answer. Okay, so these are the reasons accepted. There could be others as well, potentially. All right. So this is a kind of a proof question, just getting you to think about these kind of ideas. The lengths of the sides of a right-angled triangle are all integers. Prove that if the lengths of the two shortest sides are even, then the length of the third side must also be even. Now, this is not a case of just substituting a number in, such as, you could, here's an example, 6 and 8 are both even and they give 10, a nice answer here. But that's not a proof, that just shows that it works for one case. So to prove it, we need to do a bit more, and we need to use one of these ideas of an even number, really. If things are even, then they're multiple of 2, and I can write down my right angled triangle, and can I write one of the sides is 2n, that's a multiple of 2, and 2m, that's a multiple of 2 as well. So 2n and 2m are even sides. And it did say the shortest sides. So now I want to work out what c is, and I can use Pythagoras' theorem. It's going to be c squared is equal to 2n squared plus 2m squared, which I can then work out. If I square this, then it's 2 squared n squared, which becomes 4n squared, plus 4m squared. Okay, what to do from here? Well, actually, the mark scheme allows you to say, therefore, C is even from this, and you get all 3 marks if you just write that down. But I personally don't think that's convincing enough, and I would hope to see a bit more. At the very least, I'd like to see it factorized, and then say C squared is a multiple of 4. So C is a multiple of 2. Even. To be even more convincing, this is not expected in this question, but I think I'm going to talk about it anyway. We could actually work out C, and it's going to be the square root of this 4n squared plus m squared. And then you could use your knowledge of surds to find the square root of m times the square root of n squared plus m squared. I can do this because these two are being multiplied, and that would give me 2n squared plus m squared. Now I know this thing's going to be in an integer because it's told me all the sides are integers. This is just a more clear way now of showing that c is a multiple of 2 because it's twice something else. I could maybe even say that it's 2p, and therefore it's even. But yeah, that's how you do this question anyway.